Hey everybody, this is Larry. This is me going with 2-3 of the weekly contest 320. Minimum fuel cost to report to the Capitol. Hit the like button, hit the subscribe button, join me on Discord, hit the little bell. Let me know what you think about today's farm. So this one, I think a big part of it's reading comprehension. And I mean that in a nice way. I just mean that there's a lot of reading and you have to really understand. They kind of ask it in a way such that you have to really parse out what they really mean, right? So basically what they're doing is that given some graph, you have, everyone is trying to get to node 0, including I guess someone at 0, but they don't have to move, and in a way you're trying to figure out if they can carpool, right? So the key thing to notice is that this is a tree, and with this is a tree, there's really only one shortest path for each node, and that is going back up the tree. So here you could kind of model it as a shortest path E problem, and if you think about, and by definition, a depth first search traversal, or just a regular traversal of the tree rooted at 0 is going to be the shortest path spanning tree, right? What I mean by that is that because there's only one shortest path, because I guess you can go back and forth, but why would you? One shortest, or the one symbol path from node 0 to every node, right? So in that regard, the way that I think about it is kind of, and there are a couple of ways you can do it. You could do it with breadth first search, with queues and stuff like this. And I did this in about 3 minutes. And the way that I thought about it is that, it's kind of doing it in reverse. And what I mean by that is that starting at every leaf, start with one person and then go toward the root, right? So for example, this person at 6 will go to 4. Now there's 2 people in 4. How many cars do you need, right? And then you go up and so forth. As you get more people and as they combine, then it will take more cars. And so that's basically the idea of viewing it, right? How do you actually do it? How did I do it? The way that I did it is with a record depth first search, exploiting all the things that we kind of talk about. And it's first of all, I just created an edge list. This is just converting the roads to a list that we can parse in an easier way. And the code other than this is actually pretty straightforward, to be honest. This is just a record depth first search, but the hard part is in understanding, right? The code is always whatever. And the idea here is that, okay, this is basically the number of people going to the Capitol or node 0 from index, right? So that's basically what we're returning. And along the way, I kind of put non-local cost. You could have also returned it, I guess, in a tuple or something, but I didn't do it that way. But yeah, and the idea here is that, okay, for every node we recursively say how many people are coming from that node. And maybe another way to phrase that though is that, for example, from here, let's say you're going from 0 to the recursion 0 to 4. What does that mean, right? That means that how many people are traveling on this road from 0 or from 4 to 0 coming to the Capitol? So if there are 4 people traveling from 4 to 0, how many seats are there? Well, if there are 2, then that means that you need 2 cars, which means 2 liters of fuel. So that's basically the idea here behind this thing is that, okay, C is the number of people returning from traveling between from read to index, or from read to index, and then the cost will just be added by this much. And this is an integer only way of rounding up. If you haven't seen it before, I would say spend like 2 minutes to kind of prove it to yourself what this means. But this, because I think I get this question almost every time I write it out. Prove to yourself that this gives you, like, basically this is just seal of C seats or something like this, right? That's what this does, but keeps everything in integers, so I don't have to worry about, I don't know, floating point stuff, right? So yeah, and then that's pretty much it. And as we kind of go, we pick up people, and at the end we return total plus 1, the 1 being the person that was in this index node. So we do a depth first search and we return the sum, and that's pretty much it. This is going to be linear time, linear space, keeping in mind that the number of edges in a tree is, of course, linear in this case. It's going to be n minus 1 nodes, or n minus 1 edges for n nodes. And so, yeah, it's going to be O of n time, because you have to look at each node once, and O of n space, because that's the space complexity of the core stack of this depth first search. I was actually worried a little bit, to be honest, for this one, and I was kind of debating doing it with breadth first search because TLDR is that there are a lot of nodes, and I don't know. I hope this doesn't happen, because if it does, I'm gonna hate Leetcode even more with respect to Python. But Python function cores are kind of expensive, especially if you keep a lot of stuff on the core stack and may take a lot of memory and stuff like that. So I kind of worried about perhaps the linked list example, but hopefully, yeah, I mean, it worked okay, but who knows anymore, right? But anyway, that's all I have for this one. Let me know what you think, and you could watch me solve it live during the contest now. Okay, that was kind of a long one. Maybe there was an easier way, I don't know. Okay, it's not 10 minutes yet, so it doesn't show. Okay. It's a tree, start at 0. You have roads, and they're bidirectional. Use a coin in the city to change the road. Okay. So 0, 1, 0, 2, 0, 2. Just what does seats do again? Number of seats in each car. There's a car in each city. Okay. This is just recursion. Maybe. Right? Okay. What am I doing? Okay. Okay, what am I doing? So is there one person in each road, each place? Is that it? Okay. So then basically we want to count how many people are coming from on this road, right? So there's one person here. And then no, okay. So then here, okay, let's see. If I white phrase and here's go this, that means that they all took one, so it's gonna be C minus 1. That's how many liters. And then total, and then return total plus 1. So the reason why I do that is maybe so that I don't do the 0 case. I don't know about that. 370. Okay, let's go. Come on, big money. Also, please, no timeout. I didn't look at the, okay. Should look, I mean, it's linear, but hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy, to good mental health. Hope you did hope you had a great contest and had a good time at this prom. I'll see you later. Bye bye.